Understanding async for loops in Python. Introduction to asynchronous programming. In Python, asynchronous programming is a way to write code that can perform tasks concurrently without blocking the main thread. This is particularly useful for I/O-bound tasks, such as network operations or file reading, where waiting times can be significant. Python's asyncio module provides tools to work with asynchronous code. What is async for? The async for statement in Python is used to iterate over asynchronous iterators. These iterators yield items one at a time, similar to synchronous iterators, but they do so in a non-blocking manner. This means that while waiting for the next item, other tasks can proceed concurrently. Key concepts. 1. Asynchronous iterators. To use async for, you need an asynchronous iterator. This is an object that implements the asynchronous iteration protocol, which includes the iter and next methods. Iter. This method should return the asynchronous iterator object itself. Next. This method should return an awaitable object that yields the next item or raises stop async iteration when there are no more items. 2. Awaiting in async for loops. Each iteration in an async for loop involves awaiting the asynchronous iterator's next method. This means that async for can only be used inside an async function. 3. Non-blocking behavior. While waiting for the next item from an asynchronous iterator, other tasks in the event loop can continue running. This helps in efficiently handling tasks that involve waiting, such as network requests or file I/O. Usage and benefits. Efficient I/O operations. When dealing with I/O-bound tasks, using async for can significantly improve performance by allowing other operations to proceed while waiting for data. Concurrency. Async for enables writing concurrent code without having to manage complex threading or multiprocessing. Simplified code. It helps in writing cleaner and more readable code compared to callback-based approaches. Considerations. Compatibility. Async for is only available in Python 3.6 and later versions. Make sure your environment supports asynchronous features. Error handling. While using async for, be aware of handling exceptions and potential issues in asynchronous code, such as network errors or timeouts. Conclusion. Async for loops in Python are a powerful tool for handling asynchronous iterations. They provide a way to iterate over items from asynchronous iterators without blocking the execution of other tasks. By leveraging async for, you can write efficient and concurrent code for I/O-bound operations, leading to better performance and cleaner code. For practical use, ensure that you are familiar with the asyncio module and asynchronous programming concepts to fully utilize async for loops.